Hello, welcome to F-Grade Electronics, where we try to fix electronic devices. Today we have, let me see, an R7 374 gig from Sapphire. This is an old card. Let's see, I'm first going to disassemble the card. I don't know what's wrong with it. I don't know any of the symptoms. This screw is a little bit stiff. Is this flux here under this screw? Is this flux? Maybe. Someone might have worked on this already. Not this thing. It looks like flux. Do we have any other screws? Looks like not. Okay. We got the cooler off. Let's see. Yeah, looks like someone tried to reflow the core. Baked it in the oven, maybe. Graphics card broken. What to do? Bake it in the oven. Ooga booga. Yeah, see. Let's check the fuse first. Looks like this one is alright. We have another one here from the slot. Yeah, it's also fine. This is probably PAX. You know, it's not, it would be much lower if it was PAX. Let's see. 157 ohms. Okay. What do we have here? 5.6. This is probably Vico. It's a little bit higher than I would expect, but this is a old GPU. It was built on 28 nanometer process, so the reading might be higher than I was expecting. Let's see, this is probably 5 volts. The linear regulator for the 5 volts. This one's probably alright. Let's see. This one is probably memory. I'm going to check it from this inductor. $175 ohms. This is LPDA memory. I don't remember the value I should be getting from LPDA, but it's not assured at least. Let's see what we get from here. It's high. What is this? Okay, at least I don't see any shorts on the board. I'm going to plug it to a computer and check for some voltages. We connected the card into a computer and a power supply. Let's check for some voltages. Meter in voltage mode. Let's turn the computer on. Okay, it's on. I'm going to probe the ground from the shroud. Let's see, do we have Vico? Yes, we do. Is it getting hot? Yes, it is. What do we have here? 5 volts. Here. Yeah, 0 0.96, 0 0.95. This is PAX. It's normal. What do we have here? 12. What about memory? Do we have memory? Yes, we do. I did not check the 1.8, but if Vico and all the other voltages are running, this is probably VDDCI. If we have all the voltages, then 1.8 should be running. So let's see, do we have picture? No, we don't. Let's try to see whether the card is initialized in Linux. Here is our graphics card. I reassembled it partially and put it directly in the 16X slot and plug the HDMI cable directly to the graphics card because I want to show you something. Let's turn on the power supply and the computer. Yeah, it's running. We heard the beep. Yeah, look at the screen. We have a corrupt picture. It should be going like B A, C, D, B, A, C, D, B, A, C, D, B. It's probably A or the B channel. We can test that by using T server. Let's turn the computer off. It's off now. We are going to get our flash drive with T server. Plug it in. Okay, let's restart. No keyboard detected. Let's turn it off because I have a keyboard. Let's put it in another USB port. Yeah, it's detected now. Okay. Let's see, LSPCI. Yeah, here we can see VJ compatible controller ATI technologies. Yeah, this is our graphics card. Let's choose 370. Yeah, the test is running now. Let's wait for it to finish. It might take a long time to finish because we definitely have some memory errors. Okay, we have the report here. Let's see, channel C, channel D. Okay, channel F has some errors. Okay, half of the channel F is dead, basically. The other channels look all right. Okay, let me show you which VRAM chips, actually which VRAM chip is channel F we are seeing here on the card. Let's turn it off. And assemble the card again. Here is our card back on the bench, disassembled. We have a plastic thingy right here. Put it aside. Okay. I don't remember the exact mapping for these type of cards, like the HD7 series, R7, R9 series cards. I believe it was like A, B, C, D, E, F, G, H, and we had a problem with channel F. I'm going to take this chip off. It's some hot air. I'm going to apply some flux first. I'm going to touch it gently with my tweezers to see whether it moves. It doesn't. The solder needs to melt completely, or we can damage the traces under the VRAM chip. Be patient. Okay, it's moving now. Okay. Chip is off. Let's put it right here. My mat bulged a little bit because of the heat. Let's apply some flux and some leaded solder. And clean the pads. I'm going to get some solder wick. I'm going to use a thin one because I don't want to damage the pads. Some more flux. Okay, it looks clean now. Let's get some isopropyl alcohol and clean the area. Okay, let's see now. Do we have any damage traces? Looks like we have some. Solder mask lifted up, but we can apply some solder mask ourselves to repair it. It looks like we do not have any broken pads. Yeah, only some traces are visible because of the lack of solder mask. Yeah. Okay, I'm going to show you now how to check whether we have taken the right memory chip off. Let's get back to the computer. The card is plugged to the computer again. Now let's turn on the computer, but we're getting the display from the integrated graphics, not from the graphics card. To be able to see the screen completely without any artifacts or corruption. We are going to run the test again without the chip we have taken off. Less PCI. Yeah, we can see our graphics card here. VGA compatible controller, ATI Technologies. Let's run the test again. Yeah, we are expecting it to fail, but how it fails is the important part. I'm going to show you. Okay, we have the report. Let's see. Yeah, as you can see here now, channel F gives an error on all 32 bits. It was giving an error, but it was only 16 bits from here to the left side, from the beginning to here, and all the other 16 bits were healthy. Now, because there is no physical chip, it's giving an error on all 32 bits. If we were seeing an error like channel F 16 bits and channel G 32 bits, we could say that we have taken the wrong chip off the board. But now we are sure that this one here was the right chip. Okay, let's turn it off and replace the chip then. We need to apply some solder mask between the pads, where the tracks are clearly visible. We need to first clean the area with some isopropyl alcohol. It has to be clean. Now we can apply the UV mask. Now we are going to use some UV light to cure the mask. We are gonna wait around 3 to 5 minutes. It should be cured now. Let's see. We might have also applied some on the pads. Let's check. If we did, it's not a big problem. We can just gently scratch on the pad to reveal the pad again, like this. All the pads are shiny now. Now we need to find the same chip. This is an LPDA W4032BA BG. 512 megabytes of GDDR5 memory. Here we have a donor board. This is, let's see, this is probably an RX 470 or 570. I don't know which one exactly. But here we have the same chip, W4032BABG. Yeah, we can use this board to get the same chip. Basically, we are going to use this board as a donor. Now we are going to remove the chip the same way we removed it before. The chip is removed. Now we can put the donor card aside. Now we need to clean the pads. I'm going to apply some flux and some leaded solder. Make sure that every pad has some solder on top of it. If not, the pad might be broken. Okay, now we're going to get some wick. Just let it slide. You don't need to apply any pressure. If you apply pressure, you might damage the pads. Now the chip is ready to be reballed. Now we are going to apply some flux. Just a tiny bit of flux. This is actually too much. We only need enough to make the solder balls stick. Yeah, just a tiny amount of flux is enough. Just a thin film. Now we need to make sure that the chip is aligned with the holes. Yeah, I made sure that they're aligned. Now we need some balls, some solder balls. I'm going to use 0.45 millimeter leaded solder balls. Let's check the alignment one more time. Okay. We're going to make sure that each hole has one ball. Now we can lift the stencil. And start heating the chip with hot air. Okay, some balls moved out of their correct positions. That means we have applied too much flux. We're going to try anyways. We have the chip reballed here, and it's cleaned with isopropyl alcohol. I had to put some balls by hand because I applied too much flux. I cut it because it took a long time, and I don't want to make the video all about reballing a chip. Here's our card back. You see there is a dot at the corner of the chip right here. This should match the arrow on the card right here. First, we need to apply some flux. Not much. The amount of flux is learned while doing it. It's all about experience and the type of flux you're using. Let's put the chip where it needs to be staying. Okay. The alignment looks alright. It's going to go into its place by itself when the solder melts. This time it's going to be easier because we are using leaded solder. The factory solder melts at a higher temperature. Yeah, solder is molten now. I'm going to give just a little bit of wiggle tweezers. Yeah, it's molten. Let's wait for it to cool down and clean the board while it's still hot, but I'm going to wait just a little for the solder to harden. Let's see, is it solid? Yeah, it's solid. Now we can clean the board and the leftover flux. I also want to clean the flux from the previous cooking, I will say. It's medium rare now. I can't call it a repair. Someone tried to cook the cut. Let's also clean the thermal paste. Yeah, it's warm to touch now. Let's test the card again by plugging it into the computer. Now we have the card on the motherboard, but before turning the computer on, I want to do something because I forgot to do it. Always check for shorts after a soldering job, especially a BGA work. Yeah, the memory rail isn't shorted. in ohms range. Also check. Yeah. We have around 166 ohms. This is totally normal. Okay, let's turn the computer on and run a T-server test again. LSPCI. Yes, we have the graphics card right here. Let's run the test and see the result. Yeah. Here we have the results, and as we can see, there are no longer errors on channel F or any other channel. Looks like this card is fixed. Let's turn the computer off. Let's clean and reassemble the card and test it on Windows after installing some drivers. Here we are. We have the card reassembled and plugged into the motherboard. Let's turn the power supply on and turn the computer on. After reassembling the card, I thought, here we go, it's over. Now we are just going to test it. We already had picture. What can go wrong? Let me show you. As you can see, we have picture. It's coming from the graphics card. The Windows is loading. And we are in Windows on the desktop. Let me show you GPU-Z. It's recognized as R7 370 series, but we don't see any GPU clock or memory clock. We see the default clock, but if we look at the sensors, we don't see anything in GPU-Z. However, if we use the Radeon program, we can see that the GPU is running at 300 megahertz on the core and 150 megahertz on the VRAM, and the fan speed is 20%. Does this look like 20% to you? Let's get it all the way to 100%. The fan is now spinning at 100%. Be careful, it might hurt. Yeah, that's the problem. But let me show you something else. I'm going to turn the computer off. Watch the fans. just as it went off, the fans spun just for a moment. What does this mean? This means that the fans are all right. The fans are not broken. Something else is. And they receive the power they need. What are they missing? They're missing the PWM signal, and it comes from the core. Let me disassemble the card again and show you something. Here is the fan connector, and this is the pin for the PWM signal. This one, the closest one, is the PWM signal, and it's connected to this transistor right here. I tried to track this transistor and was able to track it for a while, but I couldn't find where this resistor, this 1K resistor, let me show you, is connected to. I checked some board views. There is no board view for this specific card. Only one I could find was a board view for R9290. And I knew that the PWM signal was coming from the core. And there are some capacitors and resistors under the core on the back side of the card. I was checking there and I saw this. This right here. Let me show you the resistance. Actually, I can't measure it because it's broken. I was able to measure it once. Now I can't. And the board view I was checking had a 10K resistor for this line. And this one was also 10K. So I believe that this resistor is responsible for the PWM signal. Let's confirm it. I'm going to use some hot air or just the soldering iron to remove this resistor from here. Let me apply some flux first. Resistor here, right here, an octave resistor. Right here. And I have a 10K resistor right here. You might not be able to see it. Let's prep the pads first. I'm going to solder on the one side. Yeah, one side is soldered. Now I'm going to take the hot air. Reduce the airflow. Let's check the resistance now. Yeah, 10K. Let's plug the card back and check again. Here we have the card reassembled again. Let's turn the computer on. To see whether we were able to fix the fan problem, and looks like we did. Yeah, we are building. Oh, the fan is very loud. It's spinning at a very high RPM because we left it at 100% before we turned the computer off. Let me fix that problem real quick. Yeah. And the fans actually stopped. This is probably the 0 RPM feature. Let's start Fermark. Let's check the clocks. 985, 1400, and at 50 degrees the fans started spinning. GPU-Z still shows 0 megahertz and can't read the clock speeds. I believe this is not a problem with this graphics card. I think it's a problem with the GPU-Z software, because the Radeon software recognizes everything. Okay, let's close Fermark and run a superposition benchmark. Let's make it 1080p high. Run. The fan stopped again. This is the 0 RPM feature. the fans don't start to spin until 50 degrees Celsius for this model. It's 60 for some cards. It depends on the model. Yeah, we have the results. And the temperatures were in a reasonable range. Yeah, this was it. The card is fixed. About the power supplies, the 5 power supply units we had, I was able to fix 4 of them. 2 of them was fixed on the video. You can check the last 2 videos. The other 2 had a problem with only the bulk capacitor. I only replaced the bulk capacitors and they are running just fine. I didn't record them because it was just a simple problem. The bulk capacitors for that. I wasn't able to fix one of them and I used it for spare parts. You can check the video for the other 2 on the channel. And thank you for watching. We successfully repaired this card. This card had 2 separate problems. We were able to fix both. Thank you for watching and see you in the next video. Goodbye.